Imagine thousands of cars in a very small radius, all honking at once. Imagine the cacophony it creates. Non-stop beeping and honking has become dominant soundtrack to Indian cities, and we provide a solution by which you can put a check to this and a host of other things that can make your travel a more pleasant experience. Vehicular noise has a staggering 72% contribution in the total noise pollution throughout the world. Through this project, we aim to find a unique solution to this problem, and additionally, our project can be used for product advertisement by companies, for security provisions by scrolling emergency messages. Now I begin with my hardware description. My hardware consists essentially of two components, a driver circuit board and the LED scroll panel. Firstly, I would like to discuss the driver circuit board. The first requirement was to select an LED that could give reasonable brightness at 10 mA and could withstand 80 mA peak current. So we devised a test circuit which forced an average current of 10 mA and a peak current of 80 mA through the LED at a 12.5% duty cycle and at a frequency of 100 Hz to be able to create the percentage sufficient required for multiplexing. Here is the circuit. We are getting a maximum voltage of 76 millivolts. The critical part was the component selection. Since we were planning to light up that's approximately 320 LEDs, we needed to come up with the figures of an average and peak currents when the alphabets were scrolled. So, apart from this, we were also required to calculate the average current requirements that would come up on a general message scrolling. So we devised a Python program. Let's say I want to scroll TI Innovation Design Contest for my scrolling. This counter here shows the number of on LEDs at any given moment of time. It increases to a steady value and then decreases. The peak value of this counter shows us the number of on LEDs, and from this we can calculate the maximum amount of current that would be drawn at any given moment of time. Next, I would like to continue with my demonstration by now showing you the schematic and board file for our scrolling project. It consists of, first, a voltage regulator IC LM2575. This is an inductor whose values we calculated so as to provide us a 5 voltage drop at the input power supply. This is a shift register for the row. This is a shift register for the column. These are the PNP transistors. These are the ULN drivers for syncing the current. These are the MO2 connectors we provided for scaling. The most important aspect of this project was the scalability, because we wished to create boards that could be replicated and then moved along easily. This is the board file. The complete board was etched, soldered in the CEDT lab which we have in our NSIT college. Now I would like to demonstrate to you the scroll panel that we created for scrolling our messages. It's a 9 by 9 LED matrix which has red LEDs of 5 mm diameters, and the holes were kept slightly less so as to the LEDs fixed. Here is the driver circuit board, and here are the aforementioned PNP transistors. Here are the shift registers. Here are the two ULN. Here are the capacitors. Here is the LM1575. Here is the MO2 connector. And these are the connections from the LED matrix to the board of rows and columns respectively. This was the Corel software that we used to create the cavities to fill the LEDs in the scrolling board. This circuit consists of an voltage regulator LM1575 IC, L157 2 ULN drivers, 8 PNP transistors, shift resistors from TI 595, capacitors, decoupling capacitors, inductor, a dedicated power supply which converts 220 volts to 5 volts DC, you can also pass important messages like drive slowly to aware other passengers and travelers. In the night time, it would look something like this. So it can be attributed that in the night time it's an important way to squall and pass messages to other fellow passengers. It can also be used to pass interesting information like cafe ahead. General information like turn to right can also be passed. Turn to right. This is a representation for the advertisement purposes. Here we show an advertisement of sales for denim being displayed at the rear windshield of a car. An additional feature of rear windshield display is that it can be controlled from via a mobile app from the phone. Make sure your phone is paired with the correct HC05 Bluetooth module which we are using here.